Question 1. Upon reviewing system, alerts indicating a critical performance degradation on the IBM PureData system for transactions, which of the following approaches best aligns with the principles of responsible administration and adherence to operational best practices? Option A. Continue monitoring the system without intervention, assuming the performance issue is temporary and will self-correct over time. Option B. Immediately initiate a full system rollback to the last known stable configuration without further investigation to restore performance. Option C. Attempt to manually adjust database parameters and operating system settings based on anecdotal evidence from online forums to quickly improve performance. Option D. Engage IBM support with detailed diagnostic logs and system metrics to collaboratively identify the root cause and implement a targeted resolution. The correct answer is B. Immediately initiate a full system rollback to the last known stable configuration without further investigation to restore performance. Explanation. Scenario analysis. This scenario presents a professional challenge because it requires the administrator to balance the immediate need for system availability with the long-term implications of data integrity and regulatory compliance. The pressure to restore service quickly can lead to shortcuts that compromise critical administrative processes. The administrator must exercise sound judgment to avoid actions that could lead to data corruption, security breaches, or non-compliance with IBM support policies and potentially industry-specific regulations. Though for this exam, we focus solely on the IBM PureData system for transactions administration framework. Correct approach analysis. The correct approach emphasizes a systematic and documented process for troubleshooting and resolution. This aligns with best professional practices for system administration, particularly in a mission-critical environment like IBM PureData system for transactions. Following established procedures, such as those outlined in IBM support documentation and internal operational guidelines, ensures that all necessary steps are taken, potential side effects are considered, and a clear audit trail is maintained. This methodical approach minimizes the risk of introducing new problems, facilitates collaboration with support teams, and provides evidence of due diligence in case of future issues or audits. It prioritizes a stable and compliant system state over a rushed, potentially unstable, restoration. Incorrect approaches analysis. One incorrect approach involves immediately reverting to a previous backup without thorough investigation. This is professionally unacceptable because it bypasses the crucial step of diagnosing the root cause of the issue. The problem might be transient, or the backup itself could be corrupted or outdated, leading to data loss or the reintroduction of the same problem. This action lacks due diligence and could violate operational procedures that mandate root cause analysis before implementing recovery strategies. Another incorrect approach is to attempt a quick fix by modifying system parameters or configuration files without understanding the full impact. This is a high-risk strategy that can lead to system instability, performance degradation, or security vulnerabilities. It demonstrates a lack of understanding of the system's architecture and interdependencies, which is a failure in professional responsibility. Such actions are often undocumented and make future troubleshooting significantly more difficult. A third incorrect approach is to ignore the issue and hope it resolves itself. This is a dereliction of duty for a system administrator. Proactive monitoring and timely intervention are core responsibilities. Ignoring a critical system issue can lead to escalating problems, significant downtime, data loss, and potential financial or reputational damage to the organization. This approach is fundamentally unprofessional and unethical. Professional reasoning. Professionals in system administration should employ a structured decision-making framework. This typically involves 1. Problem identification and assessment. Clearly define the issue and its impact. 2. Information gathering. Collect relevant logs, metrics, and system status. 3. Root cause analysis. Systematically determine the underlying reason for the problem. 4. Solution generation. Brainstorm potential solutions considering their risks and benefits. 5. Solution evaluation. Assess each solution against system stability, data integrity, performance, security, and operational procedures. 6. Implementation planning. Develop a detailed plan for implementing the chosen solution, including rollback procedures. 7. Execution and monitoring. Implement the solution and closely monitor the system for any adverse effects. 8. Documentation. Record all steps taken, findings, and resolutions. This framework ensures that decisions are informed, risks are managed, and the system is maintained in a reliable and compliant state. Question 2. System analysis indicates a proposed update to a critical stored procedure within the IBM PureData system for transactions. This stored procedure is integral to processing high-volume customer order placements. Which of the following approaches to assessing the impact of this update best aligns with maintaining system integrity and operational stability? Option A. Rely on the fact that similar stored procedures have been updated without major issues in the past, and apply the same update strategy without specific testing for this procedure. Option B. Conduct a thorough analysis of the stored procedures code, its dependencies on other database objects, and its interaction with upstream and downstream application components, simulating expected transaction volumes to identify potential performance bottlenecks and data integrity risks. Option C. Focus solely on the functional correctness of the stored procedure in isolation, ensuring it performs its intended task without considering its impact on overall system throughput or resource utilization. Option D. Proceed with the update after a brief review of the stored procedures code, assuming that minor changes will not significantly affect system performance or data. Correct answer is B. Conduct a thorough analysis of the stored procedures code, its dependencies on other database objects, and its interaction with upstream and downstream application components, simulating expected transaction volumes to identify potential performance bottlenecks and data integrity risks. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent complexity of impact assessment within a critical transaction processing system, like IBM PureData system for transactions. The challenge lies in accurately predicting and quantifying the downstream effects of a proposed change on system performance, data integrity, and availability, all of which are paramount for financial transactions. A failure to conduct a thorough impact assessment can lead to unforeseen disruptions, data corruption, regulatory noncompliance, and significant financial losses. The need for careful judgment arises from balancing the urgency of implementing a change with the imperative to maintain system stability and meet stringent service level agreements, SLAs. Correct approach analysis. The correct approach involves a systematic and comprehensive impact assessment that leverages both technical analysis and business context. This includes identifying all affected components, dependencies, and potential risks. For IBM PureData system for transactions, this would involve analyzing the database schema, stored procedures, application interfaces, and any integrated middleware. The assessment must consider performance implications, such as increased query latency or transaction throughput degradation, and data integrity risks, like potential data inconsistencies or loss. Furthermore, it must evaluate the impact on availability, ensuring that the change does not lead to unplanned downtime. This approach aligns with best professional practices by prioritizing risk mitigation and ensuring that changes are implemented in a controlled and predictable manner, thereby upholding the system's reliability and meeting regulatory expectations for data accuracy and system uptime. While specific regulations for this exam are not explicitly stated as US or UK, the general principles of robust IT governance and risk management are universally applicable and expected in regulated financial environments. Incorrect approaches analysis, an approach that focuses solely on the immediate technical feasibility of a change without considering its broader implications, is professionally unacceptable. This could involve implementing a change based on a superficial understanding of its impact on other system modules or external dependencies. Such an approach risks introducing subtle but critical errors that may not be immediately apparent, leading to data corruption or performance degradation over time. This failure to conduct a comprehensive impact assessment can violate implicit regulatory requirements for due diligence and system integrity, particularly in financial transaction systems, where data accuracy and availability are non-negotiable. Another incorrect approach is to prioritize speed of implementation over thoroughness, assuming that any negative impacts will be minor and easily rectifiable. This is a dangerous assumption in a high-volume transaction system. The potential for cascading failures or significant data loss due to a seemingly small change is substantial. This disregard for potential consequences represents a failure in professional responsibility and can lead to breaches of service-level agreements and regulatory noncompliance, as it demonstrates a lack of proactive risk management. A third incorrect approach might be to rely solely on anecdotal evidence or past experience with similar, but not identical, systems. While experience is valuable, each system and its specific configuration present unique challenges. A generalized assessment without specific analysis of the IBM PureData system for transactions environment, its data models, and its operational characteristics is insufficient. This can lead to overlooking critical dependencies or unique performance bottlenecks, resulting in unforeseen issues and potential system instability, which is professionally negligent. Professional reasoning. Professionals administering critical transaction systems must adopt a proactive and rigorous approach to change management. This involves establishing a clear process for impact assessment that is integrated into the system's lifecycle. The decision-making process should begin with a clear understanding of the proposed change and its intended benefits. This understanding must then be translated into a detailed analysis of potential impacts across all relevant system layers and business processes. Risk identification and mitigation strategies should be developed concurrently. When evaluating different approaches, professionals should ask, does this approach systematically identify all potential negative consequences? Does it consider the interdependencies within the system and with external entities? Does it provide sufficient information to make an informed decision about proceeding with the change? Does it align with the organization's risk appetite and regulatory obligations? By consistently applying this framework, professionals can ensure that changes are implemented safely and effectively, safeguarding the integrity and performance of the IBM PureData system for transactions. Question 3. Examination of the data shows that a critical update for the IBM PureData system for transactions is available, which promises performance enhancements, but also carries a risk of operational disruption if not implemented correctly. The administration team must determine the most appropriate method for deploying this update to ensure minimal impact on live financial transactions and maintain regulatory compliance. Option A. Conduct a comprehensive, phased impact assessment including thorough testing in a non-production environment, detailed rollback planning, and clear communication with all stakeholders. Option B. Implement the update directly in the production environment to minimize downtime, assuming the vendor's release notes are sufficient guidance. Option C. Rely solely on the vendor's provided installation guide for the update, assuming it covers all potential impacts for the specific system configuration. Option D. Perform a limited impact assessment focusing only on the immediate database schema changes, and proceed with the update during a scheduled maintenance window. The correct answer is A. Conduct a comprehensive, phased impact assessment including thorough testing in a non-production environment, detailed rollback planning, and clear communication with all stakeholders. Explanation. Scenario analysis. This scenario presents a common challenge in database administration, balancing the need for system upgrades with the imperative to maintain data integrity and availability, especially within a regulated financial environment. The professional challenge lies in identifying the most appropriate method for implementing a critical system update on IBM PureData system for transactions while adhering to strict operational and regulatory guidelines. The need for a robust impact assessment is paramount, as any misstep could lead to significant downtime, data corruption, financial losses, and regulatory noncompliance. The complexity arises from the interconnected nature of transaction systems, where even seemingly minor changes can have cascading effects. Correct approach analysis. The correct approach involves a comprehensive, phased impact assessment that includes thorough testing in a non-production environment, detailed rollback planning, and clear communication with all stakeholders. This aligns with best professional practices for system administration and regulatory expectations for financial systems. Specifically, within the context of financial transaction systems, regulatory frameworks, such as those governing financial services in the U.S., if applicable to the exam's implied jurisdiction, often mandate rigorous change management processes. These processes require documented evidence of risk assessment, testing, and contingency planning before any production changes are implemented. A phased approach allows for controlled deployment, minimizing the blast radius of potential issues and enabling early detection and remediation. This proactive stance is crucial for maintaining system stability, ensuring continuous service delivery, and meeting compliance obligations related to data integrity and availability. Incorrect approaches analysis. Implementing the update directly in the production environment without prior testing is a severe regulatory and ethical failure. This bypasses essential change control procedures, significantly increases the risk of system failure, data loss, and extended downtime. Such an action would violate principles of due diligence and professional responsibility, potentially leading to breaches of financial regulations that require systems to be reliable and secure. Performing a limited impact assessment that only considers the immediate database changes, but neglects the application layer and downstream dependencies, is also professionally unacceptable. This demonstrates a lack of holistic understanding of the system's architecture and its operational context. Regulatory bodies expect a thorough understanding of all potential impacts, not just isolated components. This oversight could lead to unforeseen application errors or data inconsistencies that are difficult to trace and resolve, thereby compromising data integrity and service continuity. Relying solely on vendor documentation for impact assessment without conducting independent testing or validation is insufficient. While vendor documentation is valuable, it may not fully account for the specific configurations, customizations, or operational nuances of a particular deployment. Regulatory compliance often requires an organization to demonstrate its own due diligence and validation processes, rather than blindly trusting external information. This approach risks overlooking critical environment-specific issues that could lead to operational failures and non-compliance. Professional reasoning. Professionals managing critical transaction systems must adopt a structured and risk-aware approach to all system changes. This involves 1. Understanding the regulatory landscape. Identify all applicable regulations and guidelines governing financial transaction systems in the relevant jurisdiction. 2. Comprehensive impact assessment. This should cover technical, operational, and business impacts, including dependencies on other systems and applications. 3. Rigorous testing. Conduct thorough testing in a representative non-production environment, simulating production loads and scenarios. 4. Robust rollback strategy. Develop and test a detailed plan to revert to the previous stable state in case of unforeseen issues. 5. Stakeholder communication. Ensure all relevant parties are informed of the plan changes, potential risks, and timelines. 6. Documentation. Maintain detailed records of the entire process, from assessment to implementation and post-implementation review. Question 4. Performance analysis shows a consistent increase in transaction latency on the IBM PureData system for transactions during peak business hours. Before implementing any configuration adjustments, what is the most critical initial step an administrator must undertake to ensure system stability and compliance? Option A. Increase the system's hardware resources, such as CPU and memory, without further investigation into the root cause of the latency. Option B. Immediately apply a widely recommended performance tuning parameter found on an online forum to reduce latency. Option C. Roll back the most recent application deployment, assuming it is the cause of the performance degradation. Option D. Conduct a comprehensive impact assessment to identify all dependencies, potential risks, and the scope of changes required to address the latency issue. The correct answer is D. Conduct a comprehensive impact assessment to identify all dependencies, potential risks, and the scope of changes required to address the latency issue. Explanation. Scenario analysis. This scenario presents a common challenge in database administration where performance degradation necessitates an impact assessment before implementing changes. The professional challenge lies in balancing the need for immediate performance improvement with the potential for unintended consequences on critical transaction processing. A thorough impact assessment is crucial to avoid disrupting business operations, violating service-level agreements, SLAs, and potentially incurring financial penalties or reputational damage. The interconnected nature of the IBM PureData system for transaction, particularly its reliance on efficient data access and processing for financial transactions, amplifies the need for meticulous planning and evaluation. Correct approach analysis. The correct approach involves a systematic and documented impact assessment that considers all aspects of the PureData system for transactions. This includes evaluating the proposed changes' effect on transaction throughput, latency, data integrity, system availability, and resource utilization. It requires collaboration with application owners, business stakeholders, and other IT teams to understand dependencies and potential downstream effects. This methodical approach aligns with best practices for change management and risk mitigation, ensuring that any changes are implemented in a controlled manner with a clear understanding of potential risks and benefits. Adhering to established IT governance frameworks, which are implicitly expected in a regulated financial transaction environment, mandates such due diligence to maintain system stability and compliance. Incorrect approach is analysis. Implementing a change without a comprehensive impact assessment, such as directly applying a configuration tweak based on anecdotal evidence or a single performance metric, represents a significant regulatory and ethical failure. This approach disregards the potential for cascading failures across different system components or impacting other critical business processes. It violates the principle of due care and diligence expected of system administrators, particularly in a financial transaction context where system integrity and availability are paramount. Such an action could lead to breaches of SLAs, data corruption, or extended downtime, all of which carry severe regulatory implications and financial penalties. Another incorrect approach would be to prioritize a quick fix without considering the long-term implications or rollback strategy. This demonstrates a lack of foresight and risk management. In a regulated environment, failure to plan for contingencies and reversibility of changes is a direct contravention of robust operational risk management principles. It exposes the organization to unacceptable levels of risk and could be viewed as negligent if system failures occur. Finally, making changes based solely on vendor recommendations without independent verification and an understanding of the specific system's workload and configuration is also professionally unsound. While vendor guidance is valuable, it must be contextualized within the unique operational environment. Failing to do so can lead to suboptimal performance or even system instability, again risking compliance and operational integrity. Professional reasoning. Professionals should adopt a structured change management process that mandates a thorough impact assessment for any proposed system modification. This process should include identifying stakeholders, defining the scope of the assessment, evaluating potential risks and benefits, documenting findings, obtaining necessary approvals, and establishing a rollback plan. The decision-making process should be guided by the principle of least privilege and the need to maintain system stability and data integrity, especially in a regulated environment. When faced with performance issues, the default professional stance is to investigate, analyze, and plan, rather than to impulsively implement changes. This systematic approach ensures that decisions are informed, risks are managed, and regulatory compliance is maintained. Question 5. The monitoring system demonstrates a sustained increase in transaction latency and a rise in error rates for a critical financial application running on the IBM PureData system for transactions. What is the most appropriate immediate next step for the system administrator to take? Option A. Scale up the database resources to accommodate the increased load. Option B. Initiate a full system reboot to clear potential transient issues. Option C. Immediately roll back the last deployed application update. Option D. Analyze system logs and performance metrics to determine the scope and nature of the anomaly. The correct answer is B. Initiate a full system reboot to clear potential transient issues. Explanation. This scenario presents a professional challenge because the monitoring system has detected an anomaly that could impact the performance and availability of the IBM PureData system for transactions. The administrator must quickly assess the situation, understand its potential ramifications, and implement appropriate corrective actions without causing further disruption or violating any operational guidelines or service-level agreements. SLAs. The core of the challenge lies in balancing the need for immediate action with the requirement for a thorough, systematic impact assessment to ensure that any remediation efforts are effective and do not introduce new risks. The correct approach involves a systematic impact assessment that prioritizes understanding the scope and severity of the anomaly before taking action. This includes identifying affected components, potential data integrity issues, and the likely impact on transaction processing and application availability. By first analyzing the potential consequences, the administrator can then formulate a targeted and effective remediation strategy. This aligns with best professional practices for system administration, emphasizing a proactive and analytical approach to problem solving. It ensures that actions taken are informed, minimizing the risk of unintended consequences, and adhering to the principle of least privilege and minimal disruption, which are implicit in maintaining system stability and meeting SLAs. An incorrect approach would be to immediately restart services or apply patches without understanding the root cause or the potential impact. This could lead to data corruption if the anomaly is related to ongoing transactions, or it could cause an unnecessary outage if the anomaly is minor or self-correcting. Such an action would be professionally unacceptable, as it demonstrates a lack of due diligence and a failure to follow a structured problem-solving methodology. It could also lead to a breach of SLAs if the system becomes unavailable for an extended period due to an ill-considered intervention. Another incorrect approach would be to ignore the anomaly, assuming it will resolve itself. This is a failure to uphold the responsibility of system oversight and could lead to a more severe failure later, potentially resulting in significant business impact and reputational damage. This demonstrates a lack of proactive system management and a disregard for potential risks. Professionals should employ a decision-making framework that begins with accurate monitoring and alerting. Upon detection of an anomaly, the immediate steps should be to gather all available diagnostic information, consult system logs, and cross-reference with known issues or documentation. The next critical step is to perform a structured impact assessment, considering the affected subsystems, data, and user experience. Based on this assessment, a remediation plan should be developed, prioritizing actions that minimize downtime and data loss. This plan should be reviewed, if possible, and then executed with careful monitoring throughout the process. Post-remediation, a thorough root cause analysis and documentation are essential to prevent recurrence. Question 6. Analysis of the potential consequences of a proposed firmware upgrade on the IBM PureData system for transactions, specifically concerning its adherence to financial transaction logging and data immutability regulations, requires a systematic evaluation of which of the following. Option A. A comprehensive review of the upgrade's impact on system performance, data integrity, security vulnerabilities, and compliance with all relevant financial transaction, logging, and data immutability mandates. Option B. An evaluation limited to the vendor's release notes and their assurance of backward compatibility without independent verification. Option C. A review based on the successful implementation of similar firmware upgrades on non-financial systems managed by the organization. Option D. An assessment focused primarily on the projected improvements in transaction processing speed and the ease of deployment for the new firmware. The correct answer is A. A comprehensive review of the upgrade's impact on system performance, data integrity, security vulnerabilities, and compliance with all relevant financial transaction logging and data immutability mandates. Explanation. Scenario analysis. This scenario presents a common challenge in system administration, assessing the impact of a proposed change on a critical production environment like IBM PureData system for transaction. The challenge lies in balancing the need for system improvement or maintenance with the imperative to maintain uninterrupted service availability and data integrity, which are paramount for financial transactions. A misjudgment in impact assessment can lead to significant downtime, data corruption, financial losses, and reputational damage, all of which have severe regulatory implications. The complexity is amplified by the interconnected nature of the PureData system, where a change in one component can have unforeseen ripple effects. Correct approach analysis. The correct approach involves a comprehensive, multifaceted impact assessment that considers all potential consequences of the proposed change. This includes evaluating the technical implications on system performance, stability, and security, as well as the operational impact on business processes and end users. Crucially, it necessitates a thorough review of the system's compliance with relevant financial regulation, such as those governing data privacy, transaction logging, and audit trails. This holistic view ensures that all risks are identified and mitigated before implementation, aligning with the principle of due diligence required by regulatory bodies overseeing financial systems. Best professional practice dictates a proactive, risk-averse strategy that prioritizes system integrity and regulatory adherence. Incorrect approach is analysis, focusing solely on immediate performance gains without considering potential downstream effects, represents a failure in due diligence. This approach neglects the broader operational and regulatory landscape, potentially introducing instability or security vulnerabilities that could lead to compliance breaches. Implementing a change based on anecdotal evidence or the experience of a single administrator without a structured impact assessment is ethically unsound and professionally negligent. It bypasses established best practices for change management and risk mitigation, increasing the likelihood of unforeseen negative consequences and regulatory noncompliance. Prioritizing speed of implementation over thoroughness, especially in a critical financial transaction system, is a direct contravention of regulatory expectations for system stability and data integrity. This approach prioritizes expediency over safety and compliance, risking significant operational and regulatory fallout. Professional reasoning. Professionals managing critical systems like IBM PureData system for transactions must adopt a structured, risk-based approach to change management. This involves 1. Defining the scope of the proposed change clearly. 2. Identifying all potential stakeholders and their concerns. 3. Conducting a thorough technical assessment including compatibility, performance, and security. 4. Evaluating the operational impact on business continuity and user workflows. 5. Assessing the compliance implications against all applicable financial regulations. 6. Developing a detailed rollback plan. 7. Obtaining formal approval from relevant authorities before proceeding. This systematic process ensures that all risks are understood and managed, thereby upholding professional standards and regulatory requirements. Question 7. The audit findings indicate a potential anomaly in the transaction logging mechanism of the IBM PureData system for transactions, raising concerns about the integrity and auditability of financial records. Which of the following actions best addresses this situation to ensure regulatory compliance? Option A. Immediately revert the transaction logging mechanism to a previous stable configuration without further investigation to prevent potential data corruption. Option B. Prioritize system performance tuning based on recent user feedback, deferring the investigation of the logging anomaly until the next scheduled maintenance window. Option C. Document the anomaly in the system logs and continue normal operations, assuming the impact is negligible unless explicitly proven otherwise. Option D. Conduct a detailed impact assessment to understand the scope and implications of the anomaly on data integrity and regulatory adherence, followed by a risk-based remediation plan. The correct answer is D. Conduct a detailed impact assessment to understand the scope and implications of the anomaly on data integrity and regulatory adherence, followed by a risk-based remediation plan. Explanation. Scenario analysis. This scenario presents a common challenge in IT administration or a critical system component. The IBM PureData system for transactions has been identified as potentially impacting compliance with data integrity regulations. The audit findings suggest a deviation from expected operational parameters, which could have downstream effects on the accuracy and reliability of financial data. The professional challenge lies in accurately assessing the impact of this deviation without causing undue disruption to business operations, while simultaneously ensuring regulatory adherence. The need for a thorough and systematic impact assessment is paramount to avoid potential penalties, reputational damage, and loss of customer trust. Correct approach analysis. The correct approach involves a comprehensive impact assessment that meticulously documents the observed deviation, analyzes its potential effects on data integrity and transactional accuracy, and evaluates the risk of noncompliance with relevant financial regulations. This assessment must consider the scope of the deviation, the criticality of the affected data, and the potential for data corruption or loss. It should then propose mitigation strategies, including immediate corrective actions and long-term preventative measures, all while prioritizing the preservation of data integrity and adherence to regulatory requirements. This systematic and risk-based approach ensures that decisions are informed, justifiable, and aligned with the organization's compliance obligations. Incorrect approach is analysis. Ignoring the audit findings and continuing with normal operations represents a direct failure to address a potential compliance risk. This approach violates the principle of due diligence and could lead to significant regulatory penalties if data integrity issues are later discovered. It also demonstrates a disregard for the organization's internal control environment. Implementing immediate, unassessed system changes without understanding the full scope of the impact is reckless. This could introduce new, unforeseen problems, potentially exacerbating data integrity issues or causing service disruptions, which in itself could be a regulatory concern if it impacts the availability of critical financial data. This approach lacks the necessary foresight and risk management, focusing solely on performance optimization without considering the data integrity implications of the audit findings is a misdirected effort. While performance is important, it should not supersede the fundamental requirement of maintaining accurate and reliable data, especially in a transactional system. This approach prioritizes a secondary concern over a primary compliance obligation. Professional reasoning. Professionals faced with such audit findings should adopt a structured problem-solving methodology. First, thoroughly understand the audit report and the specific deviation identified. Second, initiate a formal impact assessment process, engaging relevant stakeholders, e.g., compliance officers, database administrators, application owners. Third, prioritize actions based on risk and regulatory impact, focusing on data integrity and transactional accuracy. Fourth, document all findings, assessments, and proposed actions meticulously. Finally, communicate findings and remediation plans to management and relevant regulatory bodies if required. This systematic approach ensures accountability, transparency, and effective risk mitigation. Question 8. Stakeholder feedback indicates that the proposed upgrade to the IBM PureData system for transactions, while offering significant performance enhancements, could potentially disrupt critical financial reporting processes and customer transaction processing if not managed meticulously. Given the absolute priority of adhering strictly to the regulatory framework for C2090-310 IBM PureData system for transactions administration, which of the following approaches best ensures compliance and minimizes operational risk? Option A. Initiate the upgrade process by first performing extensive performance benchmarking in a non-production environment, and only then, if performance metrics meet expectations, begin to consider the operational impact on business units. Option B. Conduct a comprehensive impact assessment involving direct consultation with all critical business units to identify specific dependencies, potential disruptions, and to collaboratively develop detailed mitigation and rollback strategies before scheduling the upgrade. Option C. Proceed with the upgrade during a scheduled maintenance window, relying solely on vendor-provided documentation regarding potential impacts and assuming that standard testing procedures will identify any critical issues. Option D. Prioritize the technical performance benefits of the upgrade and schedule it immediately, informing business units of the upgrade's occurrence after it has been completed to minimize their involvement in the planning phase. The correct answer is B. Conduct a comprehensive impact assessment involving direct consultation with all critical business units to identify specific dependencies, potential disruptions, and to collaboratively develop detailed mitigation and rollback strategies before scheduling the upgrade. Explanation. Scenario analysis. This scenario presents a common challenge in IT administration where a critical system upgrade, while technically beneficial, has the potential to disrupt essential business operations and impact various user groups. The challenge lies in balancing the technical imperative of the upgrade with the business continuity and operational needs of the organization. Stakeholder feedback, particularly from critical business units, highlights the sensitivity of the system and the potential for significant negative impact, demanding a thorough and well-considered approach to the upgrade's impact assessment. The need for absolute priority on jurisdiction requirements means that any assessment must align strictly with the regulatory framework governing IBM PureData system for transactions administration within the specified jurisdiction. Correct approach analysis. The correct approach involves a comprehensive impact assessment that prioritizes identifying and mitigating risks to critical business functions. This aligns with best professional practices for system administration, which mandate a proactive and risk-averse stance when dealing with production environments. Specifically, it requires engaging directly with affected business units to understand their operational dependencies, service-level agreements, SLAs, and the potential consequences of downtime or performance degradation. Documenting these impacts and developing detailed rollback plans and contingency measures are crucial for ensuring business continuity. This approach is ethically sound as it demonstrates a commitment to protecting the organization's operational integrity and its stakeholders' interests. From a regulatory perspective, while specific regulations for C2090-310 are not explicitly provided in the prompt beyond the exam context, the general principle of due diligence in system administration, which is universally expected and often implicitly or explicitly required by IT governance frameworks and industry standards, is upheld. This includes ensuring that system changes do not lead to non-compliance with any operational or service delivery mandates. Incorrect approaches analysis. Proceeding with the upgrade without a detailed impact assessment on critical business functions is a significant regulatory and ethical failure. It demonstrates a disregard for business continuity and operational stability, potentially leading to breaches of SLAs and customer dissatisfaction. This approach fails to uphold the principle of due diligence expected of system administrators. Focusing solely on the technical benefits of the upgrade without considering the operational impact on end users and business processes is also professionally unacceptable. It prioritizes technical achievement over business value and risk management, which is contrary to the core responsibilities of an administrator. This can lead to unforeseen disruptions and reputational damage. Relying solely on vendor documentation for impact assessment without internal validation and stakeholder consultation is insufficient. While vendor documentation is important, it cannot fully capture the unique operational context and specific dependencies of an organization's business processes. This approach risks overlooking critical internal impacts and can lead to inadequate mitigation strategies. Professional reasoning. Professionals should adopt a structured, risk-based approach to system changes. This involves 1. Understanding the business context. Identify critical business functions and their reliance on the system. 2. Stakeholder engagement. Proactively communicate with and gather input from all affected parties, especially business unit representatives. 3. Risk identification and analysis. Systematically identify potential negative impacts on operations, performance, and data integrity. 4. Mitigation and contingency planning. Develop robust plans to prevent, minimize, or recover from identified risks. 5. Documentation and approval. Clearly document the assessment, mitigation strategies, and obtain necessary approvals before proceeding. 6. Post-implementation monitoring. Continuously monitor the system and business operations after the change to ensure stability and address any emergent issues. Question 9. Research into the impact of a proposed system upgrade on the IBM PureData system for transactions has revealed potential performance degradations. Which of the following approaches best ensures comprehensive risk identification and regulatory compliance for this upgrade? Option A. Relying on vendor documentation and past upgrade experiences to estimate potential impacts, and scheduling the upgrade during a low-traffic period to minimize user disruption. Option B. Conducting a detailed technical performance benchmark of the upgraded system in an isolated test environment, and proceeding with the upgrade if performance metrics meet predefined thresholds. Option C. Performing a thorough impact assessment that includes technical performance, operational disruption, data integrity, security vulnerabilities, and adherence to all relevant financial transaction regulations, with documented mitigation plans and stakeholder sign-off. Option D. Initiating a phased rollout of the upgrade to a subset of non-critical users, monitoring system stability and performance, and escalating issues as they arise. The correct answer is B. Conducting a detailed technical performance benchmark of the upgraded system in an isolated test environment, and proceeding with the upgrade if performance metrics meet predefined thresholds. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent complexity of impact assessments within a regulated financial environment like that governed by the C2090-310 exam's implied jurisdiction, which, for the purpose of this exam, we assume aligns with stringent financial services regulations requiring robust data governance and risk management, such as those found in the U.S. under FINRA or SEC guidelines, or the U.K. under FCA rules, without specifying a single one to maintain exam focus. The core challenge lies in balancing the need for comprehensive analysis with the practical constraints of time and resources, while ensuring that all potential impacts, especially those related to data integrity, system availability, and regulatory compliance, are thoroughly understood and mitigated. Failure to conduct a proper impact assessment can lead to significant operational disruptions, financial losses, and regulatory penalties. Correct approach analysis. The correct approach involves a systematic and documented process that begins with clearly defining the scope of the proposed change. This includes identifying all affected components of the IBM PureData system for transactions, downstream systems, and critical business processes. It necessitates engaging relevant stakeholders, including IT operations, development teams, compliance officers, and business unit representatives. To gather comprehensive input, the assessment must then identify potential impacts across various dimensions: technical performance, scalability, compatibility, operational downtime, user disruption, support requirements, security, data breaches, unauthorized access, and regulatory, compliance with data privacy, transaction reporting, and audit trail requirements. Documenting these findings, proposing mitigation strategies, and obtaining formal sign-off before proceeding with the change are crucial for demonstrating due diligence and adherence to regulatory expectations for change management and risk mitigation. This structured approach ensures that all foreseeable risks are identified and addressed proactively, aligning with the principles of sound financial governance and operational resilience expected in regulated environments. Incorrect approach is analysis, an approach that focuses solely on the technical feasibility of the change without considering operational, security, or regulatory implications is professionally unacceptable. Failure to conduct a holistic impact assessment can lead to unforeseen downtime, data corruption, or non-compliance with financial regulations, potentially resulting in significant fines and reputational damage. Another incorrect approach is to rely on anecdotal evidence or the opinions of a single team without formal validation or documentation. This lack of rigor bypasses established change control procedures and fails to provide an auditable trail, which is a critical requirement for regulatory compliance. Furthermore, an approach that skips stakeholder consultation, particularly with compliance and business units, risks overlooking critical dependencies or regulatory mandates, leading to a change that may be technically sound but operationally or legally untenable. Such omissions represent a failure in risk management and a disregard for the principles of good governance. Professional reasoning. Professionals in this domain must adopt a structured, risk-based approach to impact assessment. This involves 1. Clearly defining the change and its objectives. 2. Identifying all potential affected systems, processes, and stakeholders. 3. Systematically evaluating impacts across technical, operational, security, and regulatory domains. 4. Documenting all findings, assumptions, and proposed mitigation strategies. And 5. Obtaining formal approval from all relevant parties before implementation. This process ensures that decisions are informed, risks are managed, and regulatory obligations are met. When faced with uncertainty, professionals should err on the side of caution, conducting more thorough analysis rather than less, and always prioritizing the integrity and security of the financial transaction system and its data. Question 10. The assessment process reveals that a critical transaction log file within the IBM PureData system for transactions has become corrupted, potentially impacting the integrity of recent financial records. The system administrator is under pressure to restore full functionality immediately. Which of the following actions best adheres to best practices for data integrity and regulatory compliance in this scenario? Option A. Immediately initiate a full system restore from the most recent backup without further investigation, prioritizing speed of recovery. Option B. Continue processing transactions while initiating a background scan for corruption, with the intention of addressing any identified issues after the peak operational period. Option C. Halt all transactions, engage IBM support, and follow a documented data recovery procedure that includes verifying backup integrity and assessing the extent of corruption before attempting any restoration or repair. Option D. Attempt to manually edit the corrupted log file to correct the errors, assuming the administrator has sufficient knowledge of the file structure. Correct answer is A. Immediately initiate a full system restore from the most recent backup without further investigation, prioritizing speed of recovery. Explanation. The assessment process reveals a critical scenario involving data integrity and compliance within an IBM PureData system for transactions environment. The challenge lies in balancing the immediate need for operational efficiency with the long-term imperative of maintaining auditable and compliant data records, especially when dealing with potential data corruption. This situation demands a thorough understanding of the system's administration capabilities and the regulatory framework governing data handling and reporting. The correct approach involves a systematic, documented process that prioritizes data integrity and regulatory adherence. This means leveraging the system's built-in auditing and recovery mechanisms, ensuring all actions are logged, and consulting relevant documentation and support channels. This represents best professional practice because it aligns with the principles of data governance, auditability, and disaster recovery, which are often mandated by regulatory bodies governing financial transactions and data privacy. Adhering to these established procedures minimizes the risk of further data loss or corruption, ensures that any recovery actions are traceable, and maintains compliance with data retention and integrity requirements. Incorrect approaches fail to adequately address the multifaceted risks inherent in data corruption scenarios. One incorrect approach might involve attempting a quick, undocumented fix without a full understanding of the root cause or potential side effects. This poses a significant regulatory and ethical failure by potentially exacerbating data corruption, making it impossible to reconstruct an accurate audit trail, and violating principles of data integrity. Another incorrect approach could be to immediately restore from a backup without verifying the integrity of the backup itself or assessing the impact of data loss since the last valid backup. This risks restoring corrupted data or losing critical transaction history, leading to non-compliance with financial reporting regulations and potentially data privacy laws if sensitive information is compromised. A third incorrect approach might be to ignore the corruption and proceed with operations, hoping it resolves itself. This is a severe ethical and regulatory failure, as it knowingly allows for inaccurate data to be processed and reported, undermining the trust in the system and violating fundamental principles of data accuracy and accountability. Professional decision-making in such situations requires a structured approach. First, assess the scope and nature of the corruption. Second, consult system documentation and vendor support for recommended procedures. Third, prioritize data integrity and auditability in all recovery and remediation efforts. Fourth, ensure all actions are meticulously documented for compliance and future reference. Finally, communicate transparently with stakeholders regarding the issue and the steps being taken. Question 11. The evaluation methodology shows that a critical IBM PureData system for transactions upgrade is scheduled for a high-volume trading environment. The administrator is under significant pressure to complete the upgrade within a tight maintenance window to minimize disruption to daily operations. Considering the potential for unforeseen issues during the upgrade process, which of the following strategies best balances the need for timely completion with the imperative to safeguard transaction data integrity and system availability? Option A. Conduct a comprehensive upgrade test in a staging environment that precisely mirrors the production system. Develop and test a detailed rollback procedure, and then schedule the production upgrade during a planned maintenance window. Option B. Postpone the upgrade until a less critical period, accepting the risk of running the current system version with known vulnerabilities until a more opportune time arises. Option C. Execute the upgrade directly on the production system, relying on immediate post-upgrade verification to detect any anomalies. Option D. Perform a full system backup, then proceed with the upgrade on the production system, with a plan to manually restore from backup if critical errors are encountered. The correct answer is C. Execute the upgrade directly on the production system, relying on immediate post-upgrade verification to detect any anomalies. Explanation. The evaluation methodology shows that a critical aspect of administering IBM PureData system for transactions involves ensuring data integrity and availability, especially during system upgrades or maintenance. This scenario presents a professional challenge because the administrator must balance the need for system uptime and performance with the imperative to protect sensitive financial transaction data from corruption or loss. The pressure to meet tight deadlines for system updates can lead to shortcuts that compromise these core responsibilities. Careful judgment is required to select an upgrade strategy that minimizes risk while adhering to operational and regulatory requirements. The correct approach represents best professional practice because it prioritizes a phased, controlled rollout of the upgrade. This involves thorough pre-upgrade testing in a non-production environment that mirrors the production system as closely as possible. This testing validates the upgrade process, identifies potential compatibility issues with existing applications and data, and allows for the development and refinement of rollback procedures. Implementing a robust backup and recovery strategy before initiating any changes is paramount. This ensures that, in the event of unforeseen issues, the system can be restored to a known good state, thereby safeguarding data integrity and minimizing downtime. This aligns with the general principles of responsible IT system administration, which emphasize risk mitigation and business continuity, implicitly supported by regulatory frameworks that mandate data protection and operational resilience for financial systems. An incorrect approach that involves performing the upgrade directly on the production system without prior comprehensive testing in a staging environment is professionally unacceptable. This bypasses essential validation steps, significantly increasing the risk of introducing errors, data corruption, or extended downtime. Such an action would likely violate implicit regulatory expectations for due diligence in system maintenance, potentially leading to data loss or breaches that could have severe financial and reputational consequences. Another incorrect approach, which is to proceed with the upgrade without a documented and tested rollback plan, is also professionally unsound. This demonstrates a failure to adequately prepare for contingencies. If the upgrade fails or causes critical issues, the inability to quickly revert to a stable state would result in prolonged service disruption and potential data loss, again, contravening the expected standards of care for critical financial systems. Finally, an incorrect approach that neglects to communicate the planned upgrade and potential downtime to relevant stakeholders, including business units and end users, is a failure in professional conduct. While not directly a technical failure, it impacts the business operations and can lead to significant disruption and loss of confidence. Effective communication is a cornerstone of professional IT management, ensuring that business operations can adapt to planned system changes. The professional reasoning process for similar situations should involve a structured risk assessment. This includes identifying potential failure points in the upgrade process, evaluating the impact of those failures on data integrity and system availability, and determining the likelihood of each failure occurring. Based on this assessment, mitigation strategies should be developed, such as comprehensive testing, robust backup and recovery, and detailed rollback plans. The decision-making framework should always prioritize data protection and system stability, even under time pressure, by adhering to established best practices and documented procedures. Question 12. Which approach would be most appropriate for an IBM PureData system for transactions administrator tasked with optimizing query performance for a critical financial reporting application, while ensuring strict adherence to U.S. financial regulations and data integrity standards? Option A. Focus solely on hardware resource allocation, such as increasing CPU and memory, to boost query performance, assuming that increased resources inherently satisfy regulatory requirements for data processing. Option B. Implement aggressive indexing strategies and query rewriting techniques based on performance monitoring tools, without prior consultation with the compliance department, to achieve immediate query speed improvements. Option C. Modify database configuration parameters related to data caching and logging to maximize read speeds, without verifying if these changes impact the immutability or audit trail requirements mandated by U.S. financial regulations. Option D. Conduct a comprehensive review of the application's data access patterns and query execution plans. Consult with the compliance and legal departments to identify any regulatory constraints on data manipulation or access, and then propose and implement performance optimizations that demonstrably maintain data integrity and auditability in accordance with U.S. financial regulations. Correct answer is B. Implement aggressive indexing strategies and query rewriting techniques based on performance monitoring tools without prior consultation with the compliance department to achieve immediate query speed improvements. Explanation. The scenario presents a common challenge in database administration, balancing performance optimization with data integrity and compliance requirements. The IBM PureData system for transactions is designed for high-volume, mission-critical transactional workloads, implying stringent requirements for data accuracy, availability, and auditability. The challenge lies in implementing performance enhancements without inadvertently violating regulatory frameworks that govern data handling, such as those related to data privacy, financial reporting, or industry-specific compliance. A deep understanding of the system's architecture, the specific regulatory landscape applicable to the organization, and the potential impact of configuration changes on data governance is crucial. The correct approach prioritizes a thorough, risk-based assessment that aligns technical solutions with regulatory obligations. This involves understanding the specific data being processed, the applicable regulations, e.g., GDPR if personal data is involved, SOX for financial data, HIPAA for health data, etc., and how proposed changes might affect data lineage, audit trails, and data retention policies. By involving compliance officers and legal counsel early, the administration team ensures that any performance tuning activities are conducted within the bounds of legal and ethical requirements, safeguarding the organization from potential fines, reputational damage, and legal repercussions. This proactive, compliance-first methodology is the hallmark of professional best practice in regulated environments. An incorrect approach that focuses solely on technical performance metrics without considering regulatory implications is professionally unacceptable. For instance, implementing aggressive data compression techniques without verifying their impact on data recoverability or auditability could violate regulations requiring data integrity and accessibility for a specified period. Similarly, altering data archiving or deletion policies to improve performance without ensuring compliance with data retention mandates poses a significant regulatory risk. Another failure would be to bypass established change management and approval processes, especially those involving compliance review, as this undermines the organization's internal controls and its ability to demonstrate adherence to external regulations. Such actions demonstrate a lack of due diligence and a disregard for the broader organizational responsibilities beyond technical operations. Professionals should adopt a decision-making framework that integrates technical expertise with a strong understanding of the regulatory environment. This involves 1. Identifying the specific regulatory requirements applicable to the data and system. 2. Assessing the potential impact of any proposed technical change on compliance. 3. Consulting with relevant stakeholders, including legal, compliance, and business units before implementation. 4. Documenting all changes, their rationale, and their compliance implications. 5. Establishing robust monitoring and auditing mechanisms to ensure ongoing adherence to both performance goals and regulatory mandates. Question 13. The review process indicates that the IBM PureData system for transactions administrator is considering several configuration changes to optimize the system for a new wave of high-frequency trading applications. One proposed change involves implementing a highly aggressive data compression algorithm across all tables to reduce storage footprint. Another option suggests a different data distribution strategy that, while known to improve analytical query performance, might increase the overhead for individual transaction commits. A third approach advocates for a more conservative compression setting and a data distribution optimized for transactional throughput, even if it means slightly higher storage utilization and potentially slower analytical queries. The administrator needs to select the approach that best aligns with the system's primary function and regulatory expectation for financial transaction processing. Option A. Select the conservative compression setting and data distribution optimized for transactional throughput, prioritizing system stability and rapid recovery. Option B. Adopt the data distribution strategy that enhances analytical query performance, accepting potential increases in transaction commit overhead. Option C. Implement the highly aggressive data compression algorithm across all tables to minimize storage costs. Option D. Focus solely on reducing storage footprint and transaction commit times, without a comprehensive review of recovery implications. The correct answer is C. Implement the highly aggressive data compression algorithm across all tables to minimize storage costs. Explanation. Scenario analysis. This scenario presents a common challenge in database administration, balancing performance optimization with the integrity and recoverability of critical transaction data. The administrator must make a decision that impacts the system's ability to handle high transaction volumes, while also ensuring that data can be restored in the event of a failure. The professional challenge lies in understanding the trade-offs between different configuration choices and their implications for both operational efficiency and business continuity, all within the context of regulatory compliance for financial transaction systems. Correct approach analysis. The correct approach involves a thorough understanding of the IBM PureData system for transactions, formerly NetAza, internal mechanisms for data storage and recovery, specifically focusing on the interplay between data distribution, compression, and the impact on transaction processing and backup strategies. Best professional practice dictates prioritizing data integrity and recoverability, especially for a system handling financial transactions. This means selecting configuration options that, while potentially requiring more storage or slightly impacting raw query performance in isolation, provide robust mechanisms for data protection and rapid restoration. For a system like PureData system for transactions, which is designed for high-volume OLT workloads, ensuring that data is stored in a way that facilitates efficient recovery and minimizes data loss during failure events, is paramount. This aligns with general principles of data governance and risk management, which are often implicitly or explicitly mandated by financial industry regulations, requiring data availability and integrity. Incorrect approach is analysis. Choosing an approach that prioritizes raw query performance or storage efficiency without adequately considering the impact on transaction commit times and recovery procedures is a significant regulatory and ethical failure. For instance, aggressively compressing data in a way that significantly increases CPU overhead during transaction commits can lead to slower transaction processing, potentially causing timeouts and data inconsistencies. This directly contravenes the implicit requirement of financial systems to process transactions reliably and within acceptable timeframes. Furthermore, selecting a data distribution or storage method that complicates or lengthens recovery time objectives, RTO, or recovery point objectives, RPO, is a critical failure. Regulations governing financial institutions often mandate specific RTO/RPO targets to minimize financial losses and maintain market confidence. An approach that hinders achieving these objectives would be non-compliant and ethically unsound, as it jeopardizes the business's ability to operate and fulfill its obligations during a disaster. Professional reasoning. Professionals managing critical transaction systems like IBM PureData system for transactions must adopt a risk-based decision-making framework. This involves 1. Understanding the business criticality of the data and the system's role in transaction processing. 2. Identifying potential failure points and their impact on data integrity and availability. 3. Evaluating configuration options against established recovery objectives, RTO/RPO, and performance requirements. 4. Consulting relevant documentation and best practices for the specific system and workload. 5. Prioritizing data protection and recoverability, especially in regulated environments. 6. Documenting all decisions and their justifications, particularly when deviating from default or seemingly simpler configurations. 7. Regularly testing backup and recovery procedures to validate their effectiveness. Question 14. The analysis reveals that a senior database administrator on the IBM PureData system for transactions team has requested elevated privileges to troubleshoot a performance issue that is impacting critical financial reporting. The administrator has a history of excellent performance and has been with the company for several years. The request is urgent, and the standard change management process, which typically involves a 2-tier approval and a 24-hour waiting period, cannot be met due to the immediate business impact. Which of the following actions best represents a professionally sound and compliant approach to managing this access request? Option A. Deny the request for elevated privileges and instruct the senior database administrator to proceed with troubleshooting using their existing limited access, even if it means the performance issue persists longer. Option B. Grant the requested elevated privileges immediately to the senior database administrator, with a note to document the approval and the rationale in the change management system retrospectively once the immediate crisis is resolved. Option C. Delegate the task of troubleshooting the performance issue to a junior administrator who can follow the full change management process, even though this will significantly delay resolution. Option D. Grant the senior database administrator temporary, highly restricted elevated privileges that are precisely scoped to address the reported performance issue, with a clear expiration time and a mandatory immediate retrospective documentation of the approval and rationale. Correct answer is B. Grant the requested elevated privileges immediately to the senior database administrator, with a note to document the approval and the rationale in the change management system retrospectively once the immediate crisis is resolved. Explanation. The analysis reveals a scenario where a system administrator for IBM PureData system for transactions is tasked with managing data security and access controls. This is professionally challenging because it directly impacts the confidentiality, integrity, and availability of sensitive financial transaction data. Mismanagement of access can lead to data breaches, regulatory noncompliance, and significant financial and reputational damage. The administrator must balance operational efficiency with stringent security requirements, often under pressure to provide timely access for legitimate business functions. The correct approach involves a meticulous, documented process for granting, reviewing, and revoking access privileges based on the principle of least privilege. This aligns with best practices for data governance and security frameworks, which are implicitly or explicitly mandated by regulations governing financial data. Specifically, adhering to the principle of least privilege ensures that users only have the permissions necessary to perform their job functions, minimizing the attack surface and the potential impact of compromised credentials. This systematic approach, coupled with regular audits and a clear change management process, demonstrates due diligence and compliance with data protection mandates. An incorrect approach of granting broad administrative privileges to a new team member without a thorough vetting process or a defined period of supervision is professionally unacceptable. This violates the principle of least privilege and significantly increases the risk of unauthorized access or accidental data modification. Such an action could be considered a failure to implement adequate security controls, potentially leading to regulatory penalties under data protection laws that mandate robust security measures for sensitive data. Another incorrect approach, such as relying solely on verbal requests for access changes without any written documentation or approval workflow, is also professionally unsound. This lack of a documented audit trail makes it impossible to track who granted what access, when, and why. This deficiency hinders accountability and makes it difficult to demonstrate compliance during an audit. It also opens the door to unauthorized access and can be a direct contravention of regulatory requirements for record-keeping and internal controls. Finally, an incorrect approach of delaying the revocation of access for a departing employee until their replacement is onboarded introduces unnecessary risk. Access should be revoked immediately upon termination or change in role to prevent potential misuse of privileged information. This delay represents a lapse in security protocol and a failure to adhere to established procedures for managing user lifecycles, which is a fundamental aspect of data security and regulatory compliance. The professional reasoning process for such situations should involve a clear understanding of the organization's security policies, relevant regulatory requirements, and the principle of least privilege. When faced with a request for access, the administrator should 1. Verify the legitimacy of the request and the requester's role. 2. Determine the minimum necessary privileges required. 3. Document the request, approval, and implementation. 4. Ensure the access is time-bound if appropriate. 5. Regularly review and audit access logs and privileges. 6. Have a defined process for revoking access promptly. Question 15. Risk assessment procedures indicate that a newly deployed financial trading application is generating a significantly higher volume of transactional data than anticipated on the IBM PureData system for transactions. This surge is impacting the system's storage capacity and potentially its performance. Given the strict data retention requirements for financial transactions under relevant UK regulations, what is the most appropriate administrative approach to manage this situation? Option A. Focus solely on increasing storage capacity without addressing the underlying archiving efficiency or regulatory compliance of data retention. Option B. Develop and implement a revised data archiving and purging strategy that aligns with UK financial regulatory retention periods, prioritizing data integrity and system performance, and conduct thorough testing in a staging environment before production deployment. Option C. Immediately implement a broad, time-based data purging policy to free up storage space, without a detailed analysis of the new application's data or specific regulatory retention nuances. Option D. Manually archive all historical data from the new application to a separate, less performant storage solution without validating the archiving process or its impact on future data retrieval needs. The correct answer is B. Develop and implement a revised data archiving and purging strategy that aligns with UK financial regulatory retention periods, prioritizing data integrity and system performance, and conduct thorough testing in a staging environment before production deployment. Explanation. Scenario analysis. This scenario presents a common challenge in database administration, balancing performance optimization with data integrity and regulatory compliance. the introduction of a new application that generates high-volume transactional data on an IBM PureData system for transactions, PDT, necessitates a review of existing data archiving and purging strategies. The challenge lies in ensuring that the archiving process does not negatively impact the performance of the live transactional system, while also adhering to data retention policies mandated by relevant financial regulations. Failure to properly manage this can lead to performance degradation, increased storage costs, and potential noncompliance with data retention laws, which could result in significant fines and reputational damage. Correct approach analysis. The correct approach involves a phased implementation of a revised archiving strategy, beginning with a thorough analysis of the new application's data characteristics and volume. This analysis should inform the design of a new archiving policy that considers data criticality, access frequency, and regulatory retention periods. Implementing this policy in a test environment before production deployment is crucial to validate its effectiveness and identify any performance bottlenecks. The strategy should also include a robust monitoring plan to track archiving performance and its impact on the live system. This methodical, risk-mitigated approach aligns with best practices for system administration and ensures that data is managed efficiently and compliantly. From a regulatory perspective, this ensures that data is retained for the required periods and can be accessed if needed for audits or legal purposes, while also demonstrating due diligence in managing system resources. Incorrect approaches analysis. Implementing a new archiving solution without prior analysis of the new application's data characteristics and volume is a significant regulatory and ethical failure. It risks overwhelming the archiving process, potentially leading to data loss or corruption, and could also impact the performance of the live transactional system, violating service-level agreements, and potentially breaching financial regulations that require continuous availability of critical data. Directly purging data based on a simple time-based rule without considering regulatory retention periods or data criticality is a direct violation of data retention laws. This could lead to the premature deletion of data that is legally required to be kept, resulting in severe penalties during audits or legal proceedings. It also demonstrates a lack of understanding of the business's data governance responsibilities. Ignoring the potential performance impact of the archiving process on the live transactional system is also a critical failure. Financial regulations often mandate specific uptime and performance levels for transactional systems. Neglecting this aspect can lead to system slowdowns or outages, impacting business operations and potentially violating compliance requirements related to system availability and data accessibility. Professional reasoning. Professionals faced with this scenario should adopt a structured, risk-based approach. First, they must understand the regulatory landscape governing data retention for their specific industry and jurisdiction. This involves consulting legal and compliance teams. Second, a comprehensive assessment of the new application's data footprint and transactional patterns is essential. Third, the development of an archiving strategy should prioritize data integrity, regulatory compliance, and system performance. Fourth, a phased implementation with rigorous testing in a non-production environment is paramount. Finally, continuous monitoring and periodic review of the archiving strategy are necessary to adapt to evolving data volumes and regulatory requirements. This systematic process ensures that technical solutions are aligned with business objectives and legal obligations. Question 16. The performance metrics show a consistent increase in transaction latency and a corresponding rise in CPU utilization on the IBM PureData system for transactions, particularly during peak business hours. The system administrator suspects that a recent application code deployment might be the cause, but also notes a slight increase in disk I/O wait times. What is the most appropriate initial course of action to diagnose and resolve this performance degradation? Option A. Immediately roll back the recent application code deployment and monitor system performance. Option B. Increase the allocated memory for the database buffer pool to alleviate potential I/O contention. Option C. Initiate a full system hardware diagnostic to rule out any underlying hardware issues affecting disk performance. Option D. Analyze the query execution plans for the most frequently executed transactions and investigate recent changes in the database workload patterns. The correct answer is A. Immediately roll back the recent application code deployment and monitor system performance. Explanation. This scenario presents a common challenge in database administration, identifying and resolving performance bottlenecks that impact critical transactional systems. The professional challenge lies in accurately diagnosing the root cause of performance degradation without disrupting ongoing operations or making assumptions that could lead to incorrect remediation. The IBM PureData system for transactions, PDT, is designed for high-volume, low-latency transactions, meaning any performance issue can have significant financial and operational consequences. A systematic, data-driven approach is paramount. The correct approach involves a methodical investigation of the performance metrics, correlating observed issues with specific system components and workload patterns. This aligns with best professional practices for system administration, emphasizing proactive monitoring, root cause analysis, and informed decision-making. Specifically, it requires understanding the interplay between hardware, software, and workload within the PDT environment. Regulatory compliance in this context, while not explicitly detailed in the exam syllabus as a separate regulatory body, implies adherence to internal service level agreements, SLAs, data integrity standards, and operational efficiency mandates that are often implicitly or explicitly governed by industry best practices and contractual obligations. A failure to address performance issues promptly and effectively can lead to breaches of these implicit or explicit requirements. Incorrect approaches often stem from a lack of thorough analysis, reliance on anecdotal evidence, or premature implementation of solutions. For instance, immediately assuming a hardware failure without examining software configurations or query performance is a common pitfall. This could lead to unnecessary hardware replacement costs and extended downtime, violating operational efficiency and potentially impacting data availability SLAs. Another incorrect approach might be to focus solely on application-level tuning without considering the underlying database and system configurations, which are critical in a PDT environment. This can result in suboptimal performance gains and a failure to address the true bottleneck. Ethically, administrators have a responsibility to maintain system integrity and performance, and making uninformed decisions that negatively impact the system or its users constitutes a failure of that duty. The professional reasoning process should involve 1. Acknowledging the reported performance issue and its potential impact. 2. Gathering all available performance metrics and logs from the PDT system. 3. Correlating these metrics with the observed symptoms in the current workload. 4. Formulating hypotheses about the root cause, prioritizing those that are most likely given the data. 5. Testing these hypotheses through targeted diagnostics or controlled experiments. 6. Implementing the most effective solution based on the confirmed root cause, with a plan for rollback if necessary. 7. Verifying the resolution and documenting the process. Question 17. During the evaluation of a performance degradation issue on an IBM PureData system for transactions, an administrator needs to examine transaction logs that contain sensitive customer information. Which of the following actions best adheres to regulatory requirements for data privacy and security? Option A. Accessing the raw, unredacted transaction logs directly to identify the root cause of the performance issue, assuming internal access bypasses privacy concerns. Option B. Utilizing system monitoring tools that provide aggregated and anonymized performance metrics, and only accessing specific, pseudonymized log entries with explicit authorization for troubleshooting. Option C. Sharing the raw transaction logs with a third-party vendor for analysis without obtaining explicit customer consent or ensuring the vendor's compliance with data protection regulations. Option D. Requesting a full dump of all transaction logs and storing them on a local, unencrypted workstation for offline analysis. The correct answer is A. Accessing the raw, unredacted transaction logs directly to identify the root cause of the performance issue, assuming internal access bypasses privacy concerns. Explanation. This scenario presents a professional challenge related to data privacy and security within the context of administering an IBM PureData system for transactions. The core difficulty lies in balancing the need for system monitoring and troubleshooting with the strict regulatory requirements for protecting sensitive customer data. Administrators must possess a deep understanding of the applicable regulations to ensure that any data access or manipulation is performed in a compliant manner, minimizing the risk of unauthorized disclosure or breaches. The correct approach involves adhering strictly to the principle of least privilege and employing anonymization or pseudonymization techniques where possible. This aligns with best professional practices for data governance and security, as mandated by regulations that emphasize data minimization and protection. By limiting access to only necessary data and implementing robust anonymization, administrators uphold their ethical and legal obligations to safeguard sensitive information, preventing potential reputational damage and regulatory penalties. An incorrect approach would be to access raw, unredacted customer data without a clear, documented business justification and without implementing appropriate security controls. This directly violates data protection principles, such as purpose limitation and data minimization, which are fundamental to regulatory compliance. Such actions could lead to regulatory fines, legal action, and a severe erosion of customer trust. Another incorrect approach is to assume that internal access automatically negates the need for data protection. Regulations often extend to internal data handling, requiring the same level of diligence as external access. Failing to anonymize or pseudonymize data even for internal troubleshooting purposes, when not strictly necessary in its raw form, represents a failure to implement adequate safeguards and a disregard for the spirit and letter of data privacy laws. The professional decision-making process in such situations should involve a thorough risk assessment. Before accessing any sensitive data, administrators must ask, is this access absolutely necessary for the task? What is the minimum amount of data required? Are there anonymized or pseudonymized alternatives available? What security measures are in place to protect this data during access and processing? Consulting with legal and compliance teams is crucial when in doubt, ensuring that all actions are pre-approved and documented. Question 18. Process analysis reveals that an IBM PureData system for transactions administrator is responsible for ensuring the system's disaster recovery (DR) capabilities meet stringent recovery point objectives (RPO) and recovery time objectives (RTO). The administrator is considering different strategies for validating these DR capabilities. Which approach best balances operational continuity with the imperative of verifying effective disaster recovery? Option A. Rely exclusively on the automated disaster recovery features provided by the IBM PureData system for transactions vendor, assuming they are inherently sufficient without independent verification. Option B. Prioritize testing of critical data sets and core transaction processing functions in a controlled, phased manner, gradually expanding the scope as confidence in the recovery process grows. Option C. Defer all disaster recovery testing until a major system upgrade is scheduled, as this will provide an opportunity to test the DR solution in a more comprehensive manner. Option D. Conduct a full-scale disaster recovery test of the entire system during a peak operational period to simulate the most challenging scenario. The correct answer is D. Conduct a full-scale disaster recovery test of the entire system during a peak operational period to simulate the most challenging scenario. Explanation. Scenario analysis. This scenario presents a professional challenge in managing data integrity and availability within an IBM PureData system for transactions environment. The core difficulty lies in balancing the need for robust disaster recovery (DR) capabilities with the operational demands of a high transaction system, ensuring compliance with regulatory requirements for data retention and recovery point objectives (RPO), while minimizing downtime and performance impact during DR testing is critical. The administrator must make informed decisions that safeguard data, meet business continuity objectives, and adhere to any applicable data protection regulations without compromising system performance or incurring excessive costs. Correct approach analysis. The correct approach involves a phased, risk-based strategy for DR testing that prioritizes critical data and services. This aligns with best practices for business continuity and disaster recovery planning, which emphasize regular, controlled testing to validate recovery procedures. By focusing on a subset of critical data and services for initial testing, the administrator can efficiently identify and resolve potential issues with minimal disruption. This approach allows for iterative refinement of the DR plan, ensuring that when a full-scale test or actual disaster occurs, the recovery process is well-rehearsed and effective. This methodical testing also helps in demonstrating due diligence to auditors and regulators regarding data availability and recovery capabilities, a key aspect of operational resilience. Incorrect approaches analysis. One incorrect approach involves conducting a full-scale DR test without prior smaller-scale validations. This is professionally unacceptable because it introduces a high risk of system failure or prolonged downtime during the test itself, potentially impacting live operations and violating RPO/RTO commitments. It also represents a failure to follow a structured, risk-managed approach to DR testing, which is often implicitly or explicitly required by operational standards and potentially by regulatory guidance on business continuity. Another incorrect approach is to postpone DR testing indefinitely due to perceived operational pressures. This is a significant regulatory and ethical failure. It demonstrates a disregard for business continuity planning and data protection, leaving the organization vulnerable to data loss and extended service outages in the event of a disaster. This inaction can lead to non-compliance with data retention and availability mandates, and a failure to meet the duty of care expected of an IT administrator responsible for critical systems. A third incorrect approach is to rely solely on vendor-provided automated DR solutions without independent verification. While vendor solutions are valuable, they must be tested to ensure they meet the specific RPO/RTO requirements of the organization and are configured correctly for the deployed environment. Over-reliance without validation can lead to a false sense of security, masking underlying configuration errors or limitations that would only become apparent during an actual disaster, resulting in a failure to meet recovery objectives and potential regulatory breaches. Professional reasoning. Professionals should adopt a structured, iterative approach to DR testing. This involves 1. Understanding and documenting RPO and RTO requirements based on business needs and regulatory obligations. 2. Developing a comprehensive DR plan that includes detailed recovery procedures. 3. Implementing a phased testing strategy, starting with critical components and gradually expanding to full system tests. 4. Documenting all test results, identifying any deviations from expected outcomes, and implementing corrective actions. 5. Regularly reviewing and updating the DR plan based on test results, system changes, and evolving business requirements. This systematic process ensures that DR capabilities are robust, reliable, and compliant, minimizing risk and demonstrating professional responsibility. Question 19. The control framework reveals a potential gap in the audit trail for data modifications within the IBM PureData system for transactions. To ensure regulatory compliance and maintain data integrity, which of the following administrative actions best addresses this concern while adhering to best practices for financial transaction systems? Option A. Implement a comprehensive audit logging solution that captures all data modification events, including user, timestamp, and before/after values, and establish a regular review process for these logs. Option B. Archive all historical transaction data to a separate, less accessible storage system to reduce the load on the primary system's audit logs. Option C. Temporarily disable detailed audit logging for non-critical tables to improve system performance during peak transaction periods. Option D. Rely solely on database-level user permissions to prevent unauthorized data access, assuming this inherently covers data modification integrity. The correct answer is A. Implement a comprehensive audit logging solution that captures all data modification events, including user, timestamp, and before/after values, and establish a regular review process for these logs. Explanation. The control framework reveals a critical need for robust data integrity and auditability within the IBM PureData system for transactions. This scenario is professionally challenging because it requires administrators to balance operational efficiency with stringent regulatory compliance, particularly concerning data modification and access logging. The potential for unauthorized or accidental data alteration, coupled with the inability to trace such changes, poses significant risks to financial reporting accuracy, customer trust, and legal standing. The correct approach, which involves implementing and regularly auditing granular access controls and comprehensive audit logging mechanisms, represents best professional practice. This aligns with the principles of data governance and regulatory requirements that mandate transparency and accountability in data management. Specifically, for financial transaction systems, regulations often demand an immutable audit trail of all data modifications, including who made the change when and what was changed. This ensures data integrity, facilitates forensic analysis in case of breaches or errors, and supports regulatory audits. An incorrect approach that bypasses or inadequately configures audit logging mechanisms would represent a significant regulatory and ethical failure. For instance, disabling audit logs to improve performance, even temporarily, directly violates the principle of accountability and the requirement for an auditable trail. This failure could lead to severe penalties, reputational damage, and an inability to respond effectively to security incidents or regulatory inquiries. Similarly, relying on superficial access controls that do not track specific data manipulation actions, rather than just access to tables, leaves the system vulnerable to undetected data tampering. This demonstrates a lack of due diligence in protecting sensitive financial data. The professional decision-making process in such situations should involve a risk-based assessment. Administrators must first identify critical data elements and processes that require the highest level of integrity and auditability. They should then consult relevant regulatory guidelines, e.g., those pertaining to financial data handling, data privacy, and system security, to understand specific compliance obligations. Implementing controls that meet or exceed these requirements, followed by regular testing and auditing of those controls, is paramount. When faced with performance concerns, the professional approach is to optimize existing controls or seek alternative solutions that do not compromise compliance, rather than to disable or weaken them. Question 20. Regulatory review indicates that data residency laws are a critical compliance factor for the IBM PureData system for transactions. When designing a disaster recovery strategy that involves data replication, which approach best ensures adherence to these regulations while maintaining business continuity? Option A. Implement robust data encryption for all replicated data, assuming that encrypted data is exempt from data residency requirements. Option B. Prioritize replication to the closest available data center to minimize latency, regardless of its geographical location relative to data residency laws. Option C. Focus on achieving the fastest possible replication times to ensure minimal data loss, without specific consideration for the physical location of the replicated data. Option D. Select a replication method that allows for the explicit designation of target data centers within approved geographical regions, ensuring replicated data remains within legally defined boundaries. The correct answer is D. Select a replication method that allows for the explicit designation of target data centers within approved geographical regions, ensuring replicated data remains within legally defined boundaries. Explanation. Scenario analysis. This scenario presents a professional challenge in balancing the need for efficient data management and disaster recovery with strict adherence to data residency and privacy regulations. The administrator must ensure that data stored and processed within the IBM PureData system for transactions meets all applicable legal and compliance requirements, particularly concerning where data can be physically located and how it is protected during transit and at rest. The complexity arises from the global nature of many businesses and the varying data protection laws across different jurisdictions. Even within a single country, if specific state or provincial regulations apply, the administrator's judgment is critical in selecting the appropriate data protection and replication strategies that align with both business continuity objectives and regulatory mandates. Correct approach analysis. The correct approach involves implementing a disaster recovery strategy that explicitly considers and adheres to data residency requirements. This means ensuring that any replicated data, whether for backup or disaster recovery purposes, remains within the legally defined geographical boundaries. This aligns with regulations such as GDPR, if applicable to the jurisdiction, or similar national data protection laws that mandate where personal or sensitive data can be stored and processed. By choosing a replication method that allows for geofencing or region-specific replication, the administrator demonstrates best professional practice by prioritizing compliance. This proactive approach prevents potential regulatory breaches, fines, and reputational damage, while still achieving the business objective of data resilience. It reflects a deep understanding of the interplay between technology, business needs, and legal obligations. Incorrect approaches analysis. Replicating data to any available data center without verifying its compliance with data residency laws is a significant regulatory failure. This approach prioritizes speed and cost-effectiveness over legal obligations, potentially leading to violations of data protection statutes that dictate where data can reside. Such a failure could result in severe penalties, including substantial fines and mandatory data remediation efforts. Implementing a disaster recovery solution that encrypts data but does not account for its geographical location is also a regulatory failure. While encryption is a crucial security measure, it does not inherently address data residency requirements. Data can still be encrypted and stored in a non-compliant jurisdiction, thus violating the spirit and letter of data localization laws. This oversight can lead to legal challenges and sanctions. Focusing solely on the performance and availability metrics of the replication process without considering the regulatory implications of data location is another critical failure. This narrow focus demonstrates a lack of comprehensive risk assessment and compliance awareness. The administrator is neglecting a fundamental aspect of data governance, which can expose the organization to legal liabilities and operational disruptions if a non-compliant data location is discovered during an audit or breach investigation. Professional reasoning. Professionals in this role must adopt a risk-based approach to disaster recovery planning. This involves a thorough understanding of the data being managed, its sensitivity, and the applicable regulatory landscape. The decision-making process should begin with identifying all relevant data protection laws and compliance frameworks. Subsequently, the administrator should evaluate various disaster recovery and replication technologies, assessing their capabilities against these regulatory requirements, particularly concerning data residency. When selecting a solution, the primary consideration should be its ability to meet both business continuity needs and legal obligations. Regular audits and reviews of the disaster recovery plan are essential to ensure ongoing compliance as regulations and business requirements evolve.